Have you ever just stopped and wondered how an app like Instagram actually works? I don't mean the filters and the stickers, but the massive engine underneath it all that has to handle billions of photos. So, what if you had to build it from scratch? Let's give it a shot. Let's design a global photo sharing service right now.
It really all boils down to this one question. How do you take a simple idea, hey, let's share photos with our friends, and scale it up to handle the traffic of a medium-sized country? That is the puzzle we are going to solve together today.
So, to get there, we've got a clear roadmap. First, we need to wrap our heads around the sheer scale of this thing. Then, we'll sketch out a high-level blueprint, pick the right tools for the job, figure out how to split up our massive database, and finally, we'll tackle the most important feature of all, the newsfeed. All right, before we write a single line of code, we have to understand the numbers. Because when you're designing systems, scale changes everything. Let's start with our users. We need to support 500 million of them. That's our starting point, a massive global user base that expects the app to be fast and reliable, no matter where in the world they are. And get this, every single day, those users are uploading 2 million new photos. Just think about that for a second. That breaks down to about 23 new photos hitting our servers every single second, all day, all night. So where do all those photos go? Well, over 10 years, that adds up to over 1,400 terabytes of data. That is an absolutely astronomical amount of storage we need to manage efficiently and, most importantly, never, ever lose. Not a single photo. Okay, so now that we're properly terrified by the scale of this problem, let's start building. It's time to draw our initial architectural blueprint. And this is a really great illustration of our starting point. Up at the top, you've got a user uploading an image. It goes to a dedicated upload service, which then saves it to image storage. Simple enough. Down at the bottom, another user wants to view an image. That request hits a totally separate download service, which fetches the photo's information, its metadata, and then the photo itself. Notice how we have two different paths for uploading and downloading? That's on purpose. Yeah, that separation is intentional and it is absolutely critical. See, uploading a photo, what we call a write, is a pretty slow process. It has to physically save a file to a disk. But viewing a photo, a read, needs to be lightning fast. If we put them on the same servers, those slow uploads would just jam up all the connections, blocking everyone from seeing photos. So we split them. That's one of the key first steps to keeping the app feeling responsive. Okay, so we have a plan for the actual photo files. But what about the data about the photos? Who uploaded it, where it was taken, when, the likes, the comments. For all that stuff, we're going to need a database. Now, you might immediately think of a traditional database, something like MySQL. And they're amazing for structured data, don't get me wrong. But they simply can't handle the constant flood of read requests at a global scale. They would just become a massive bottleneck. This is where NoSQL databases come in to save the day. They are literally built for this exact scenario, massive amounts of data distributed across tons of servers. They trade some of that strict consistency you get from traditional databases for incredible speed and scalability, which is exactly the trade-off we need to make. And we're not just going to use one type of NoSQL database. We're going to use the right tool for each job. The photo files themselves, they go into a distributed system like Amazon S3. Perfect. All the other data, the photo info, user relationships, that's going into different types of NoSQL databases, each one optimized for what it does best. For example, looking up a photo by its ID has to be instant. Tracking who follows whom involves these huge lists, so we pick the best tool for each specific task. So even with all these amazing NoSQL databases, we can't just put all our data on one giant server. It would eventually fail. We need a strategy to split it all up, and that technique is called data sharding. Sharding is actually a pretty simple concept. It's just the process of breaking up one giant database into a bunch of smaller, more manageable pieces called shards. Think of it like turning one massive, messy filing cabinet into a whole room full of smaller, perfectly organized cabinets. It's just easier to work with. So how do we decide which photo goes into which shard? Well, we could shard by UserID. That seems logical, right? It keeps all of a person's photos together. But what happens when a celebrity, a hot user, uploads a photo? Their shard gets absolutely hammered with traffic, while all the other shards just sit there, idle. The better approach is to shard by PhotoID. This spreads the data out perfectly evenly. The only catch is, we need to get a unique photo ID before we even know which shard to put it on. So how do we generate that unique ID before we save the photo? With a really clever trick. We set up 2 dedicated database servers, and their only job in the world is to generate numbers. But here's the genius part. One is configured to only create odd numbers, and the other one only creates even numbers. When we need a new photo ID, we just ask either one. This gives us a globally unique ID every time. And, crucially, it removes any single point of failure. If one server goes down, the other can still handle every single request. Brilliant. Okay, we've built the back end, we can store photos, and we can find them. Now for the magic, crafting that fast, engaging, and personal newsfeed for every single user. This is what it's all about. So how do we get new photos to the user? We could use a pull model, where the app is constantly asking the server, anything new? Anything new now? This leads to delays and a lot of wasted requests. Or we could push updates from the server as soon as they happen. This is great, but just try to imagine pushing a new photo to the 50 million followers of a celebrity user all at once. It's just not efficient. The solution is usually a hybrid, a smart combination of the two. But the real secret to a lightning-fast feed is this. Instead of building it on the fly when the user opens the app, we pre-generate it. We have dedicated servers constantly building everyone's feed in the background. So the moment you open the app, your feed is already built. It's just sitting there waiting for you. And we can make our system even smarter by understanding a key pattern, the 80-20 rule. In a system like this, it turns out that about 80% of all the views go to just the top 20% of photos. A small number of photos are incredibly popular. This pattern is our secret weapon for performance. We use this knowledge to build a really smart cache. For that popular 20%, we keep their data in memory, using something like Memcached, which is way faster than going to the database. And for the photo files themselves, we use a content delivery network, or a CDN. This is awesome. It basically places copies of popular images on servers all around the world, physically closer to our users. So a user in Tokyo gets the photo from a server in Tokyo, not one in California. This dramatically reduces loading times. And there you have it, a blueprint for a global photo sharing service. But the work is never truly done. System design is a constant cycle of building, measuring, and fixing the next problem. We've solved today's challenges, but the real question is always, what's the next bottleneck? Thanks for joining me on this design journey.